Good morning, fellow Earth scientists. This is Mr. Avery, Miss Teven. We're going to get you ready for the Oceanography test, Unit 5, coming up next week. Our recommendation is that you watch this video several times to get ready for the test. We're going to cover the main points that's on the test. One of the things that there are lots of questions on is the seafloor bottom. So let's go over the seafloor bottom so you can get it straight in your head before the test. So we have parts of the seafloor bottom, and we know that we can map the seafloor bottom using bathymetry. Bathymetry is like topography, shows the seafloor bottom, but the technology for that is sonar. Sonar can send sound waves down to figure out what the seafloor bottom features are. The first part of the seafloor starts with the continent, where it reaches the beach, reaches land. We know that the rock that's on the continent is, we call it granite. It's a igneous rock that's intrusive, and it's made out of granite. Once we get over here to the ocean floor, it transitioned into basalt. This is an extrusive igneous rock called basalt. So there's two main types of rock. So let's go over the continent side first. The first thing we call is the margin. The continental margin up here. The continental margin consists of the shelf, slope, and rise. So this is all still part of the continent. There's just parts of it is still underwater, but technically it's still part of the continent. The first part we call the shelf. The shelf is the first part from the beach on out to about 50 miles in Virginia. We call it the shelf. In the shelf is where we get most of our natural resources like oil, gas, and minerals. That's like the first 50 miles is the shelf. Then the part that slopes down, we call it the continental slope. The part that slopes down after the shelf, it slopes down. The very bottom of the slope, we call it the rise, the continental rise. That's the part at the bottom of the slope down here where everything through erosion, deposition, and weathering, everything rolls downhill and it stops down here. So we call it, do I even have one? I thought I had one. Nope. It's gone. So down here we get the weathering, erosion, so it all stops right there. Now the start of the seafloor, where the basalt is. The first part we come across is called the abyssal plain. That's the flat part of the ocean that has really no features. It's just all flat through here. Next we come to the mid-ocean ridge down here. The mid-ocean ridge is where the seafloor is actually separating. It's separating. And it's coming apart right here, and this is all filled with magma coming up right here, and when it reaches the surface we call it lava. So it makes these ridges across here, and the seafloor is actually separating, so we call that a divergent boundary because it's separating. And because this is all shooting up new magma and lava in here, we call it new young seafloor. So any place where there's, so this is all separating going this way out, and it makes new seafloor as we go. The next one is down here, we call this the trench. The trench is the deepest part of the ocean, right? Like the Marianas Trench. And what's happening here is it's a convergent boundary. So these plates are coming together. They're coming together, and then the basalt plate is more dense. Over here, the ocean plate is more dense, and it comes underneath the granite, which is less dense. So we talked about density. Basalt comes under, so when it happens like this, it's called subduction. It's a subduction zone. So it's coming down. Can you get that part? Mm-hmm. Subduction zone. So it's coming down, and that's what's causing the trench right in here. All right, so now we've got the last one's called, we got the margin, the plate. So there's a couple more. We got one called the volcanic island. So if it's a seamount that reaches the surface and is shooting up lava, we call it a volcanic island. If it's underwater, we call it a seamount. So these over here is a seamount. It's still underwater. If it has a flat top on it and it's been weathered to the top, we call it a guyout. Okay, that's the seafloor bottom. Go.
Okay, Earth scientists, I'm going to speak to you about ocean circulation. So here's the thing about the ocean. We've got 3 zones right here. We have our surface zone, and our surface zone is well mixed. We have waves, we have winds mixing it, and it's pretty much a steady temperature. And we know that when it goes, the deeper you go, the lower the temperature goes. And when you have a rapid decline in temperature, we call this zone the thermocline, okay? And after a certain point, depending on your latitude, we have the deep ocean. And you see, that's a steady temperature. So some interesting things happen. We've got currents going on. We have surface currents. We have surface currents. And surface currents tend to be caused by global winds. Okay? And in the deep ocean, we have something called density currents. Okay? Now you remember in Finding Nemo, when those turtles took the current to Sydney, they were using a density current. Okay? It was a little bit warmer, a little bit faster. And these are caused by density differences, and density is influenced by salinity and temperature. So, if there's an increase in salinity and a decrease in temperature, we get a more dense current, okay? So, I'm going to show you a globe right here, and we're going to talk a little bit about the ocean conveyor belt. Basically, how water on our planet mixes. Basically, in earth science, we talk about one big ocean. We know the coldest water comes from the North Pole and the South Pole. This water mixes with the warm water from the lower latitudes around the equatorial region. This is an example of convection. You need to remember that. Convection with a V. Heat transfer in water and wind. Okay? Convection with a V. Convection is how heat is transferred in water and wind.
Okay guys, you know a couple of questions about the Chesapeake Bay. We know the Chesapeake Bay is an estuary. The definition of an estuary is a semi-enclosed body of brackish water. What is brackish water? Brackish water is fresh and salt mixed together. The fresh coming from the rivers and the salt water coming from the oceans. A watershed. The Chesapeake Bay is a huge watershed, which means it's an area of land that drains into the same body. So all of these rivers flow into the Chesapeake Bay are called watersheds. You got to know the term watershed. You got to know the term eutrophication. Eutrophication is too much fertilizer in the bay from farmers and landowners, and it makes the algae grow, which becomes toxic in the bay. We call that eutrophication. So basically, the fish need oxygen too. They can't get to the oxygen, so the fish die because there's too much algae. That's eutrophication. It's a big problem in the bay, especially in the summer months. How can we help save the bay? Through education, educating you, the student, and the general public. We can reduce, reuse, and recycle things, so we're putting less things in the bay, and we need stricter legislation and laws to help save the bay. Study for the test, guys. Your test is coming up soon. Watch this video. Be ready, no excuse.
Okay, we're going to talk about some ocean motions here. This is a tsunami. A tsunami is caused by an underwater earthquake. It is not weather related. It's a huge wave caused by plate tectonics. Spring tides. This happens twice a month, every new and full moon. Keep in mind, when you have the setup of sun, moon, earth, we have a new moon. Sun, earth, moon. Full moon. Remember, spring tide starts with an S. Straight line. Okay? You have your highest high tides and your lowest low tides. Neap tide. This is when the moon is at a right angle. Sun, earth, moon. Okay? Or sun, earth, moon here. Anytime we have first quarter or last quarter moon, we get a neap tide. This is a low high tide or a high low tide. Basically, the tides cancel each other out. This is a 24-hour period, and in this 24-hour period, you see one high tide, one low tide. That is a diurnal tidal pattern. Where you and I live, we have a semi-diurnal pattern. That means in a 24-hour period, we have 2 high tides and 2 low tides. The Gulf Stream, we spoke a little bit about currents, and we have a current that goes along the equator, goes along the Gulf of Mexico, the southern part of the United States. It is warm. It brings us a lot of warmth. That is called the Gulf Stream. And it also influences places as far as Great Britain. Okay, so it makes Virginia warmer and more humid. In contrast, California, or the West Coast, gets a current called the California current coming from the poles. Therefore, it is cooler. Okay, so although these places may be the same latitude, we know that San Diego has a cooler climate than a place like Charleston, South Carolina. Why? The Gulf Stream brings warmth and humidity to places on the East Coast, whereas the California current keeps a lot of places along the West Coast cooler. And that is it.